Hello dear students. So today here I am with a new topic. Okay, the electrochemical series. So in the previous lecture, in the previous video, I have when I have explained you about the standard hydrogen electrode. Okay, and there I said that using the standard hydrogen electrode as a reference, we can find out the standard electrode potential of different metals. Okay, different electrodes, we can find out the standard electrode potential, because it is not possible for us to find out the electrode potential of a metal individually. Okay, we need some kind of reference electrode. Okay, and say we want to find out the electrode potential of zinc metal or copper metal or silver or gold, like that. So what do we do? How do we find out that? Because we know that since in a redox reaction we need both the half cells. Okay, so we cannot find out individually if we want to find out the standard electrode potential of a individual metal, right? So for that, what do we do? For that, one method is there, that whichever metal, whichever electrode we want to find out the standard electrode potential, we will keep it and we will take one reference with it, which is the standard hydrogen electrode generally taken, right? And these two we will connect with the everything the same, the setup we will make, like the electrochemical cell is set up. And then what will happen, the voltmeter, whatever reading will be shown in the voltmeter, it will be the standard electrode potential of the this metal, your particular metal, because we know that the standard electrode potential of a standard hydrogen electrode, by definition, it is kept at 0 volt. Okay, so like that I have explained you in the previous video. Okay, now, so likewise, for every metal, the standard electrode potential is taken out. Okay, and they have been arranged in a series. So you just listen that the standard electrode potential of the different metals, they have been taken out by using this method only, whatever I have said you, by using this standard hydrogen electrode as a reference, and they have been arranged in a particular series with respect to the hydrogen. Okay, and this series of the metals, okay, the electrode potential of the metals, and it is taken out at standard conditions, like 2 mole concentration of the solution. Okay, and everything. So that series, particular series, is known as the electrochemical series. So I hope it is clear what is the electrochemical series. So once we know what is electrochemical series, we will go into the detail of why do we need this electrochemical series, or what is the use of it, or what observation we can make by looking at the electrochemical series, right? So electrochemical series is nothing but it is the arrangement of the metals with their standard electrode potential calculated. Okay, and it is arranged with comparison to the hydrogen, standard hydrogen electrode, right? So now I am going to show you the electrochemical series. So this is the electrochemical series. Okay, you can see here, you will find out in your NCERT books also, but I thought that I should give you explanation here only, right? So here you can see that in these here, this part. Okay, so you can see how the metals, the electrodes, they have been arranged, right? And this is the standard electrode potential of the your these, if it is for fluorine, so this is the standard electrode potential for the fluorine metal, and this is in volt. Already we know that the cell potential or the electrode potential is, it is measured in terms of volts, right? So likewise, what you can see that I'll show you, that all the metals, they have been arranged, you can see. Okay, you can see how many metals are there, right? Other substances are there, right? So you can see all these are arranged in a series, right? So this is the electrochemical series. So this series, there are various methods by which you can like learn it. So if I get time, I will find you a trick for learning this electrochemical series, but I will suggest you that in your exam it is not important for your that you should by heart it, but for some metals you need the values, you need to memorize the values for some metals, okay, like zinc, like copper, because all these are repeated in the exam. And sometimes what happens in your numerical only you will get the values, so no, sometimes you get the values, but we cannot take the risk. So the common elements whatever comes in the exam, we just memorize it. And if it is possible for your competitive exams, if you memorize the whole series, it is well and good. So I will find you a trick to memorize this in the next or the other video, okay? So you can see here. So now you see what one observation what you will see is that as you go from top to bottom, I'll show you the like the in the top the fluorine is there, right? Here fluorine is there. So the value of fluorine, the electrode potential of fluorine is what? The fluorine the is what? 2.87. Now as you go, you can see the values are decreasing. You can see from 2 to 1 point, like 0 point, like this. And one more thing here I'll show you, that here you see the hydrogen is there, because all other values we are comparing based upon the hydrogen, right? This is the hydrogen. You can see the what is the electrode potential of hydrogen, it is 0 volt, already I've said you, right? So compared to the hydrogen only, the electrochemical series is constructed, okay? The reference is hydrogen, remember. See, for example, if I ask you what is your height, so what you will tell, right? What you will tell. So if you are standing say at the ground floor, will tell your height based upon some reference, like the floor, right? So your floor is acting as a if you are telling that I'm 5 feet tall, that means from what at what ground you are telling that you are 5 feet tall? You are measuring your height from some reference, there is some reference, right? So the reference is the ground, right? So from the ground you are 5 feet tall. Likewise, for measuring the standard electrode potential, there is a reference point, and that is the hydrogen electrode, okay? So it is kept at 0 volt, the electrode potential of hydrogen. Now you can see that, as you already have said you, that as you are going down the group, okay, here you can see the values are decreasing, decreasing, and ultimately it is in negative, okay? So the above values, these elements which are in the top of the series, they are greater, the numbers are greater, right? Positive values. And as you go down, they are getting smaller and smaller, and the last one is negative, right? So this observation is very important. Now what we will see is that as we go down the group, the values of the electrode potential are decreasing, they are negative values. Now down the series, the means below hydrogen, okay, this is the hydrogen, this is the reference point, right? This is our reference point. So whatever elements you will find below hydrogen, no, they are very strong reducing agents. Whatever elements you are finding below the hydrogen in the series, they are very strong reducing agents. That means the reducing character increases. You can see here it is written, the reducing character of the elements of the metals, it increases as we go down in the series compared to the hydrogen. Okay, that means what it means is that the last element of the series, the last metal of the series, which is the lithium, okay? So this lithium, okay, this the last in the series is the strongest reducing agent, the strongest reducing, because you know that the reducing character is increasing as we are going down in the series. That means the last element is the strongest reducing agent, means the negative values, the more the negative value, more is the reducing, more is the oxidizing character, because we know we are talking about the redox reaction. If I'm talking about reducing, there will be oxidizing. Now what will be what will happen then? So as we are moving down, the reducing character is increasing. That means as we are going up, the oxidizing character is increasing. Right here it is written, you can see the this one, the oxidizing character is increasing. As we go high up, what will happen, the oxidizing character will increase, and the, like, if we go like this, so oxidizing character is going on increasing and the reducing character is going on decreasing. Similarly, if we go down, the reducing character is increasing and the oxidizing character is decreasing. It is vice versa, because we are talking about the redox reaction. So that means what, the fluorine, okay, which is top in the series, this one. So you can see the value is highly positive, right? So that means this fluorine is, it is a strong oxidizing agent. It is a strong oxidizing agent. Okay, strong oxidizing agent. And the weakest reducing agent. Always the vice versa will be there. If it is a strong oxidizing agent. Now students, you already know that what is a reducing agent and what is a oxidizing agent. So reducing agents, if I tell oxidizing agents, what is the meaning? Oxidizing agents, they are capable of what, accepting electrons. The oxidizing character is based upon the ability to accept electrons. Okay, whenever we talk about the oxidizing nature, it is the ability to accept electron. I think that you should note down this, because you will forget it. It is what it is. Yes, it is normal, you can forget, right? So you just note down that oxidizing nature, whenever we tell, we are talking about the electron accepting tendency of the anything. If we are talking about that means this fluorine, if I say it is the strong oxidizing agent, that means it has the ability, it has the strongest ability to accept electron. And also you know that one more logic is there, that fluorine is highly electronegative. So it will not it is not favorable for fluorine to give electron. It will accept electron because it is electronegative, the most electronegative, right? So that's why from this logic also you can understand that fluorine is the strongest oxidizing agent, and hence it is kept in the top of the series, and the electrode potential value is highly positive. Okay, and when I talk about the reducing agent, so what is reducing agent? So reducing character means the ability of the substances to release electron. जितना इलेक्ट्रॉन रिलीज करने का टेंडेंसी होगा एलिमेंट्स के पास, इतना ही वो रिड्यूसिंग कैरेक्टर शो करेगा. दैट मीन्स वी विल से दैट इट इज अ रिड्यूसिंग एजेंट. और ऑक्सीडाइजिंग एजेंट किससे होगा, किससे पता चलता है? ऑक्सीडाइजिंग कैरेक्टर इससे पता चलता है कि इलेक्ट्रॉन कितना एक्सेप्ट कर रहा है कोई भी मेटल या कोई भी सब्सटेंस. दैट इज द ऑक्सीडाइजिंग कैरेक्टर ऑफ दैट मेटल. एंड रिड्यूसिंग कैरेक्टर मतलब क्या, कि वो कितना इलेक्ट्रॉन रिलीज कर रहा है. ओके, वो उसका रिड्यूसिंग नेचर हम लोग को पता चलेगा. अगर ज़्यादा इलेक्ट्रॉन रिलीज कर रहा है, दैट मीन्स इट इज़ मोर रिड्यूसिंग. ठीक है, सो दैट मीन्स जो लास्ट में है सीरीज में, ऑलरेडी मैंने बोला कि रिड्यूसिंग कैरेक्टर बढ़ रहा है. दैट मीन्स जो लिथियम जो लास्ट में है सीरीज का, ये सबसे ज़्यादा इलेक्ट्रॉन रिलीज करेगा. इट हैज़ द टेंडेंसी, हाइएस्ट टेंडेंसी टू रिलीज इलेक्ट्रॉन. ठीक है, हम लोग को ये पता है कि लिथियम, दे आर ऑल दीज, पोटेशियम, calcium, all these are group 1 group 2 elements, right? And we know that group 1 group 2 elements, they are the alkali metals, and they have the last shell is 1 electron, the valence shell है, hence is very much feasible for them to donate this electron, right? Alkali metals electron donate करते हैं जो उसका last shell में है. ठीक है, so for by doing that they get this stability, and that's why ये जो last में arranged है metals, right, इन लोग का टेंडेंसी क्या है, इलेक्ट्रॉन रिलीज करने का टेंडेंसी. एंड दैट्स व्हाई वी से दैट ये लोग कौन सा एजेंट एक्ट करता है, रिड्यूसिंग एजेंट. अभी एजेंट तुम लोग को पता होगा, जैसे LIC, वी डू LIC, राइट? देयर आर एजेंट्स फॉर दैट. सो व्हाट आर दीज एजेंट्स? वी हैव वन LIC, right? And we have the policy. So to bridge the gap between the two, we want some policy. We cannot go to the LIC directly, so we take our agent, right? So agent acts as a bridge. Similarly, these agents like the reducing agent, the oxidizing agent, they help in doing the oxidation. So if some substance is helping in the oxidation process, that means they are oxidizing agent. And if some element is helping in the reducing agent, reducing nature, reduction करने में help करेगा. कैसे help करेगा? By donating the electron, right? So they are acting as a reducing agent. Simple. So I think that you should note down all these whatever I have said you. So here two things are very much clear, that down the note these electrochemical, or it is there in your book, and you can note down all these small points. So down the group, whatever elements you will find, they are more reducing in nature, and more reducing in nature means they can release electron, they have the tendency to release electron. That means they are undergoing oxidation. Three things. First of all, the elements present in the bottom of the series, they are strong reducing agents. Note down, strong reducing agents. Okay. Second thing, that they have the ability to release electron easily. Release electron easily. Okay. And the third point is that they undergo the process of ऑक्सीडेशन, बिकॉज वी नो दैट इलेक्ट्रॉन जहाँ पे रिलीज होगा वो प्रोसेस को हम लोग क्या बोलते हैं, ऑक्सीडेशन, राइट. सो थ्री थिंग्स यू विल नोट डाउन. एंड वट एवर वी आर लर्निंग रिलेटिव टू द हाइड्रोजन. ठीक है, हाइड्रोजन से ज़्यादा, ठीक है, हाइड्रोजन से कम, लाइक दैट. And whatever elements are placed at the top of the series, okay, they are strong oxidizing agents. Strong oxidizing agents, okay, example fluorine. They are capable of accepting electron, not donating, accepting electron, right. Third number point, they undergo reduction, because reduction में electron accept होता है, right. Reduction process अलग है, reducing agent अलग है. You do not get confused between reduction and reducing agents, okay. So I think that these 2 points, these 2-3 points are very much clear to you. So electrochemical series ka ek point is very much important, because there are multiple number of questions they can form you. The examiner can form from this electrochemical series. Okay, this is a conceptual thing you should understand. So here I have written everything like that. Whatever I just spoke now is all written here, right? And one more thing, students, I forgot that, see, the reactivity, no, reactivity of a metal, the reactivity of any metal, if I say, is always expressed in terms of its electron releasing tendency. See, I am telling in Hindi that किसी भी मेटल का रिएक्टिविटी हम लोग कैसे बोलेंगे, वो मेटल कितना इलेक्ट्रॉन रिलीज कर सकता है इन सोल्यूशन, ठीक है, कंपेयर टू हाइड्रोजन, दैट इज इट्स रिएक्टिविटी. अगर वो ज़्यादा इलेक्ट्रॉन रिलीज करने का टेंडेंसी है उस मेटल का कंपेयर टू सम अदर मेटल, वी विल से दैट दिस मेटल इज मोर रिएक्टिव. मतलब रिएक्टिविटी हमेशा इलेक्ट्रॉन रिलीज करने का टेंडेंसी के ऊपर बेस्ड करके रिएक्टिविटी हम लोग बोलते हैं. से एग्जाम्पल आई विल शो यू दैट सपोज कॉपर जो है इलेक्ट्रोकेमिकल सीरीज में, इफ यू सी, यू जस्ट सी इट, कॉपर इज प्लेस्ड बिलो द सिल्वर, ठीक है, सिल्वर Ag, राइट. दैट मीन्स कॉपर का इलेक्ट्रॉन रिलीज करने का टेंडेंसी ज़्यादा है, ऑलरेडी हैव सेड यू, राइट. कॉपर इज प्लेस्ड बिलो सिल्वर, दैट मीन्स द it is more reducing in nature. It is more reducing in nature means it can release electron more easily, right. And that's why this copper, we say that between copper and silver, which will be more reactive, the copper will be more reactive than silver, because it has the more electron releasing tendency. Always the reactivity we will measure in terms of its electron releasing tendency, or we can say that in its from its reducing behavior. Electron releasing tendency means its reducing behavior. So this point is also very important, because sometimes they may ask you between the some metals, they will give you and they will say you that arrange these metals in terms of its reactivity. So you have to do based upon the electrochemical series, and for that electrochemical series is sometimes important for you to memorize. So here I have written everything whatever I spoke. Okay, so you can just note down from here if you want. See, these all things are just for conceptual clarity. They will So this is important for you to note down, because I know you will forget it. So one more part is there, so I will do another video for that part. Okay, so here I'm just ending this video, and if you have any doubt, you please ask me. Okay, thank you so much.